Hi everyone, today we are going to start graphing quadratics by looking at vertex form. In this video you are going to be able to apply your knowledge of the quadratic parent graph, and then we're going to use transformations just like we did in the previous unit to graph functions that are similar to the parent function. And then the last thing we're going to do that is new is if we're given a picture or graph, we're going to be able to write the quadratic equation using vertex form. So first let's go ahead and talk about vertex form. If you look over here, you'll see that I've given you the general form for vertex form. This is a formula that is not going to be provided to you, so it is one that you do need to memorize. I want you to notice a couple of similarities between it and the absolute value equations we were working with last time. You still have h inside of the brackets. This time we have parentheses with a square instead of absolute value bars, but it's still with the x variable. On the outside of that, we still have the a value being multiplied out front, and we have k being either added or subtracted on the equation as well. So a, h, and k are going to do the same things that they did in our previous unit. The difference is that the shape is going to change. Instead of having that V shape from the absolute value bars, we're going to have a curve because of this square here. And so we're going to have this kind of U-shaped function. You can see here this blue one is the parent function. So we're going to have a couple of small differences between absolute value and vertex because it's a curved shape. So for the description of shape, I'm going to put a U shape. And this U shape is called a parabola. All right, so let's talk about some transformations first. In terms of the h value, the number inside with the x, that is still going to move our parabola left or right, the same way that we were moving our absolute value V shape. The sign is going to tell us to do the opposite, just like in the previous chapter as well. The vertical shifts, that k value, is still going to do the same thing as well. It's going to move the parabola either up or down, the same way that happened in our last chapter. The dilation is going to do the same thing as well. If we have the absolute value of a is greater than 1, meaning it is a number like 2 or 3 or an improper fraction like 3 over 2, our parabola is going to vertically stretch. And if our a value's absolute value is between 0 and 1, meaning a proper fraction, the parabola is going to vertically compress. So most all of that except the shape is the same. The direction of opening is also going to be the same. When the a value is greater than 0, the parabola is going to open up, and when the a value is less than 0, meaning a negative number, the parabola is going to open down. The one major difference is this shape. That is not a straight line or a set of straight lines, this U shape. We are not going to use a as slope. That is not going to be the case here because it's not a straight line, it's a curve. We're going to have to use a squaring pattern in order to get our U shape. So please be very, very clear about this. HK does the same thing. The dilations and direction of opening, we're using the same vocabulary, but the pattern that we're following is not slope. All right, so let's do a couple of examples of graphing without a calculator so that we can see what happens with this. So the first thing we're going to do is just the parent function. Y is equal to x squared. So if I were to write this in where'd my mouse go? If I were to write this in vertex form, then I would have 1 times the quantity, x minus nothing squared, plus nothing. What I've done here is I've given you an a value of 1, an h value of 0, and a k value of 0. So our vertex is still going to be 0, 0. And we can take the nearby x values and plug them in to get the rest of this table, which will give us the U shape. So I have 0, 0. I'm going to pick x's that are close to my vertex. So I'm going to pick 1 and 2, and I'm going to pick -1 and -2. You're always going to start with your vertex and then pick x's that are nearby. I pick integers, don't pick fractions, it just makes it harder. Okay, so now what we're going to do is plug and chug. We're going to take 1 and we're going to put it into our function. Y is equal to the quantity 1 squared, which is just 1. When we put in 2, 2 squared is 4. So notice this is not increasing at the same rate like it was before. If I put in -1, the quantity -1 squared, that's -1 times -1 is +1. And when I put in -2 squared, -2 times -2 is +4. So something that I'd like for you to notice here is that I have symmetry happening. My middle, my vertex is 0, 0, but then I have 1, 1 on the positive side and a y value of 1 on the negative side too. I also have these 4s on both sides. That's because the shape is symmetrical. The two halves of it are the same. So really, I don't have to do this 4 times. I can do it 2 times and then mirror it over to the other side. So let's graph this. We have 0, 0 as our vertex, and then at 1, it's +1. At 2, it's +4. At -1, it's +1. And at -2, it's up as 4 as well. If I were to go one more, 3 over 3 squared is 9, so it would put us up here, and -3 squared is also 9. So you'll notice here that I have a more curved shape. This is not a straight line, it's a curve. And I'm using that squaring, so I go over 1 and up 1 squared, I go over 2, up 2 squared, over 3, up 3 squared to get that shape. So let's talk about characteristics now. An absolute minimum is the very lowest point on the graph. So this one has an absolute minimum at its vertex, which is 0, 0. Absolute max is the very highest point because this one's end behavior goes up forever on both sides. There is no highest point, so there's no absolute maximum. A relative minimum is a turning point that's relatively low, so that's just our vertex again, because it changes from decreasing to increasing. There's no relative maximum because there's no hill where it changes directions from increasing to decreasing. And then the zeros are just the x-intercepts, and this one only has 1 here at the vertex, so the zeros are 0, 0. Alright, so let's do another one that has some transformations this time. This next one has the quantity x plus 3 squared minus 9. The a value is still 1 in this one. The h value is our number inside. Remember, that comes from our formula that you're working on memorizing. We are going to use the opposite sign here. So because that says +3, I'm going to use -3. And then the k value is still the number being added or subtracted on the outside, and I do not change that sign. So my vertex in this one is -3, -9. Alright, so, goodness, it went way too far. Alright, so now let's do our table. We're going to put our vertex in the center, -3, -9, and then I'm going to pick x values that are nearby. So I'm going to pick numbers like -2 and -1, which are bigger than -3, and -4 and -5, which are smaller. So now we're going to do some plugging and chugging. We're going to take -2 and plug it into our function. So that's -2 plus 3, quantity squared, minus 9. So -2 plus 3 is 1, 1 squared is 1, and 1 minus 9 is -8. When I plug in -1, that's -1 plus 3, quantity squared, minus 9. -1 plus 3 is 2, 2 squared is 4, 4 minus 9 is -5. And then because this is symmetrical, I'm going to make my other sides match. Okay, and now I am ready to graph. So I'm going to put my vertex in first. That's -3, -9. Then at -2, it's at -8. At -1, it's up at -5. My other side is symmetrical, and so that gives me my curve. This one also has an absolute minimum. It's at the vertex, -3, -9. This one opens up, so there is no maximum, so that's none. The relative minimum, the turning point that's down low, is the same as the absolute minimum, so that's -3, -9. There's no relative maximum. And for my zeros, I have to go a little bit further on this one. So I'm going to show you a cool pattern that will help you if this table feels like a lot of work to you. We could keep going with the table until we got there, but that's a lot of work. So notice that if I start at my vertex, when I go over 1 unit to the right, I went up 1 squared. If I go back to my vertex again and go over 2 units, 2 squared is 4, and that is how far I went up as well. I went 1, 2, 3, 4 and drew my spot. So if I go over 1, 2, 3 units, 3 squared is 9. So if I go up 9, that puts me here. And if I go the other way, 1, 2, 3, and up 9, that puts me there. So you can plug in 0 and do the plug and chug, and you'll get that 0, 0 is an ordered pair, and that means at -6 it's at 0 also. But we can also use that squaring pattern to do more of our curve after we have the vertex. You're always going to start at the vertex and go over and then square how far you go up for those. The A value is going to make that pattern a little bit weird in some other ones, and we'll look at that in a moment. But for now, our zeros are -6, 0, and 0, 0, because we have 2 x-intercepts. All right, so now let's move on to another example that is a little bit different. Notice in this one, there are 2 things that are a little weird. First is there's an A value that's negative, which means it's going to make the graph open down, and there isn't a number on the outside being added or subtracted. That K value is not there. So let's talk through what this means. The A value is going to be -1. The H is the number that's inside. We're going to change the sign, so that's +1. And then if we had to put a plus sign here to make it follow the formula, what could we add on that does nothing to it? Adding? Well, adding 0 is like adding nothing. So that means our K value in this one is 0. Our vertex then is 1, 0. So I'm going to put that in the center, and then I'm going to pick some x values close by. So I'm going to pick 2 and 3, and I'm going to go the other direction and pick 0 and -1. Now it's time to plug and chug. So I'm going to put in 2. So that's negative quantity 2 minus 1 squared plus 0. So 2 minus 1 is 1, and then I have negative quantity 1 squared. So order of operations says to do powers and then to do multiplication. So I'm going to do 1 squared is 1, and then I'm going to make that negative. That goes on my other side as well. And now I need to plug in 3. So negative quantity 3 minus 1 squared. 3 minus 1 is 2, so I'm doing negative quantity 2 squared. 2 squared is 4, and then I multiply that by my negative, so that means -4 goes in both of those symmetrical spots. Okay, so let's graph. I have 1, 0 as my vertex. I have 2, -1. Okay, so this one's going down like we expected, and 3, -4. So that goes there, and then I make my other side symmetric, and there's my U shape. Notice that this one goes down because of that negative A value. This one does not have an absolute minimum because the ends go down forever. There's no bottom. It does have a maximum this time though. The vertex is that maximum. Notice that the vertex is always going to be for a parabola either the minimum or the maximum, both relative and absolute when we're working with quadratics. We don't have a relative min, but our vertex is our relative max as well. and our x-intercepts are zeros, is 1, 0. It happens to be the vertex in this one too. Okay, so let's do one more that's a little bit harder, just for a last example of graphing. So in this one, we have an a value of 2, which means we're going to have a vertical stretch. We have an h value of -1 and a k value of -3. So our vertex is going to be -1, -3, and we're going to put that in the center of our table. Okay, so we're going to pick some numbers that are close by, like 0 and 1, -2 and -3 on the other side, and then we're going to plug and chug. So we have 2 times 0 plus 1, quantity squared, minus 3. 0 plus 1 is 1, and then when we, sorry my computer's acting up so much today guys, it is getting a little old. Alright, so 0 plus 1 is 1, 1 squared is 1, 2 times 1 is 2, 2 minus 3 is -1, and that goes on the other side as well. And then we need to plug and chug with the 1 as well, so 2 times 1 plus 1, quantity squared, minus 3. 1 plus 1 is 2, 2 squared is 4, 2 times 4 is 8, and 8 minus 3 is 5. So that goes on both sides as well. So let's graph. I have -1, -3. I have 0, -1. Ooh, yeah. And 1 is up at 5. Then I'm going to make my other side symmetric. Notice that this parabola is more narrow than the other ones that we've graphed. If I needed to go 1 point further, let's look at that pattern that we were looking at initially. If we start at our vertex and go over 1 unit, 1 squared is 1, but we have to multiply that by a. So we're going up 2 units there. 1, 2. If I go back to the vertex again and go over 2 units, 2 squared is 4, but we have to multiply that by a. So we need to go up 8 units. When we go 1, 2, 3, 4, 5, 6, 7, 8, that puts us at this ordered pair. If I need to go 3 units, that's 1, 2, 3 units over. 3 squared is 9, multiplied by 2, so I have to go up 18 spots, which is going to actually put me off the graph, I think. But that pattern is still the same. You square how far you go to the left or the right, but then you multiply it by the a value to see how far you have to go up, because it's getting stretched up or doubled according to this problem's a value. All right, so absolute minimum is the vertex in this one. That's -1, -3. There's no absolute maximum. The relative minimum is also -1, -3. And there is no relative maximum. Okay, now do you notice for this one that the x-intercepts are not nice pretty numbers, right? They cross at a fractional point. So let's use one of our graphing tools to figure out the exact zeros. I'm going to pull up my calculator here. We'll do one in the calculator and we'll do one with Desmos so you get a reminder on how to use both. Okay, so I've already plugged into my y equals here. I'm going to hit graph. It's going to take a moment. There it is. And now let's find this one on the left over here. So I'm going to hit second trace because I'm trying to find an x-intercept. That's a 0, so I'm going to choose option number 2, and it's going to ask me some questions now. First it says left bound, so I need to move that cursor so that it's on the left-hand side of my x-intercept. So I'm going to move it over a bit so that when I hit enter and it draws that line, the line is on the left-hand side of the x-intercept I'm trying to find. Then it changed and it said right bound, so I'm going to move back to the right so that I'm on the right-hand side of the x-intercept. I'm going to hit enter again. So notice now my x-intercept is in between those 2 dotted lines that are the bounds, and it's asking me for a guess, which is the last thing it'll ask for. So I'm going to put it back over where the x-intercept is and hit enter. And then it's going to tell me that's at 2.2247. Let's round to 3 decimal places for this one. So that is negative 2.22. That 4 is going to round up because there's a 7 after it to 5. So that's my ordered pair with a 0. And then let's do the second one in Desmos. You could do it in the calculator, but Desmos is nice too, so let's review that. Okay, so I'm going to exit out of my PowerPoint and pull up Desmos. Now you can see I've also already graphed this one here. So all I'm going to do is I'm going to click on the parabola, and it tells me the one that I just found with the calculator and also this other one, which is at 0.225. Notice that you also have the vertex here and the y-intercept. So if you want to check your work on anything, you could do that if you had access to Desmos here. All right, so that means then to finally answer this last piece of this question, I've got 0.225, comma 0 as my other ordered pair for my x-intercepts. All right, so the last thing that we need to do besides just being able to graph is being able to look at a graph and figure out the equation. So when we do this, we are going to get 2 pieces of information from the graph. Obviously, you have to have the vertex first. So in this one, it looks like the vertex is 2, negative 4. That's this point here. And then I need one other point. It doesn't matter which one it is. I'm going to use this guy here, because it has a 0 in it, and I like working with zeros. So that is 0, negative 2. So we're going to use that general form, that formula that we talked about and used a moment ago. What we're going to do here is we're first going to take our vertex and plug it in for HK. So I'm going to leave everything else the same, but I'm going to put in my H. It's a positive 2, so I'm going to write negative 2, and I'm going to put in my K, minus 4. Then I am going to take that other point that I just identified, this 0, negative 2. The 0 is x, and the negative 2 is the y value of that ordered pair. So I'm going to plug in 0 and negative 2 for the x and for the y in this equation. So the y is negative 2, and the x is 0. And what this does is it leaves me with just one variable, a. So now I can solve for a, and then I'll have my entire equation, because I already know this part of the equation. I know what h and k are, but I have to know what a is as well. So let's solve this for a, and then we'll have all 3 pieces of information that we need. So we're going to do negative 2 is equal to a times 0 minus 2 is negative 2, quantity squared minus 4. Then I have negative 2 squared that I need to do next for order of operations. So that is 4. I'm going to write this because it's a times 4 as 4a. Then I've just got algebra 1, so I'm going to add 4, which makes that 2 is equal to 4a. And then I'm going to divide by 4, because those will divide out. And that leaves me with a is equal to 2/4, which is a fraction that reduces, because they're both divisible by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2, which means my a value is 1/2. So I've almost got my full equation here. I have my h and my k, and now I know my a is 1/2. Notice that that is a proper fraction, which means that this is a compressed parabola. So when we look over here at that pattern, when we go over 2 units, 2 squared is 4, so normally we'd go up 1, 2, 3, 4, but we only went up half of that. We only went up 2, and that's because 4 times our a value of 1/2 is 2. So that's how far I went up. So this squaring pattern and multiplying by the a value is a good way to check your work to make sure you got the a value right. And it's also something anytime you need to graph, you're able to use as a shortcut instead of the table if you want. Okay, so in this video we talked about the parent function for a quadratic graph, and then we talked about those transformations of A, H, and K to get all of our other graphs that we might need to graph. And the last thing that we did was we were given a graph and we figured out what the vertex form of the equation was. So go ahead and try the Now You Try now.